Hi students, this is Naveen. Today I am going to explain about Kirchhoff Laws. In 1842, a German physicist, his name is Gustav Kirchhoff, he just extended the Ohm's law to the complicated circuits and finally he gave two laws. Those two laws are Kirchhoff's first law and Kirchhoff second law. Now if you have a doubt, sir, why we have to learn these two laws? We have Ohm's law, we have series combination and parallel combination, we have the derivations and we have the formulas for series and parallel. Why we have to do these two laws? First, suppose in a given circuit, if you are unable to identify the combination properly, if suppose in the given circuit the voltage sources is increases and the components is increases, we are unable to find out which one is series, which one is parallel. We are unable to apply the Ohm's law directly. In that case, by learning these two laws enable us to determine the potential difference as well as current in any complicated circuit. Simply, just remember these two laws enable us to determine potential difference and current in any complicated circuit. For solving the complicated circuits, we must know about the Kirchhoff first law and second law. This is the purpose to know these laws. In this session, I am going to explain about Kirchhoff's first law. Now you know the reason why we have to learn this concept to determine the potential difference or current in the complicated circuit. By the help of these laws, we can solve the circuits very easy. Now, the Kirchhoff first law is also known as junction law. It is clear. It is also known as junction law. According to Kirchhoff first law, in any electric circuit or in a electric circuit, the sum of the currents or the algebraic sum of the currents meeting at any junction point is equal to 0. In a electric circuit or in any electric circuit, the algebraic sum of the currents meeting at any junction point is equal to 0. This is according to the first law. Now, what is this law? How to elaborate this one? How to identify the junction point? How to identify whether the sum of the currents are equal or not? For that, I will take one part of the electric circuit. Let us assume here the current I1 passing through this resistor, here the current I2, here the current I3 and current I4. Now this is the junction point. What they are given in a electric circuit, the algebraic sum of the currents meeting at any junction point. This is the junction point. At this junction point, the algebraic sum of the currents equal to 0. Algebraic sum of means we have to represent the current with respect to the sign conventions also. I will take, if the current is moving towards the junction, let us consider the current is moving towards the junction, I will take positive. the current is moving away from the junction, that is negative. Remember, current moving towards the junction, this I1 moving towards the junction, it will be positive. Plus the current is moving away from the junction, negative, minus I2. Here I3, the current moving towards the junction, it will becomes plus I3, and the current moving towards the junction, plus I4, is equal to 0. I can write I1 minus I2 plus I3 plus I4 is equal to 0. It is also written as I1 plus I3 plus I4 is equal to I2. According to Kirchhoff's first law or junction law, the sum of the incoming currents, the algebraic sum of the incoming currents at the junction point is 0. It is also written as the sum of the incoming currents I1 plus I3 plus I4. These are the incoming currents. I1, it is towards the junction. I3, it is towards the junction. And I4, it is also flowing towards the junction. These three currents, the sum of the incoming currents towards the junction is equal to the sum of the outgoing current from away from the junction. From this, I can also written as, or we can also say that sigma I is equal to 0. Nothing but the summation of the total currents is equal to 0. This is according to the Kirchhoff's first law. It is clear? According to the Kirchhoff first law, it states that in any electric circuit, the algebraic sum of the current at a junction point is equal to 0, or the sum of the incoming current. This is the junction point. Let us assume this is the junction point. The sum of the incoming currents is equal to sum of the outgoing currents. We can also write the sum of the incoming currents is equal to sum of the outgoing currents. This is according to the Kirchhoff first law, or we can also write as sigma I is equal to 0. Nothing but the sigma shows the summation. The total currents must be equal to 0. And this law is based on conservation of charge. This law is based on conservation of charge. From this, we can say that whenever the current flowing from one point to another point, the current cannot store at any point in a given circuit. It is clear? This first law is based on conservation of charge. By this, we can say that if the current is flowing from one point to another point, let us assume the current is flowing from one point to another point. This is I1, and this is I2, and this is I3, and this one, it is I4. This current is cannot store at any point. It have to flow. Due to this, we can say that the sum of the incoming currents is equal to sum of the outgoing currents, or at a junction point, the sum of the algebraic sum of the currents equal to 0. From this, how to write I1 incoming, I4 incoming is equal to I2 plus I3. There I1 plus I2 is the sum of the incoming currents towards the junction. I2 plus I3 is the sum of the outgoing currents away from the junction. The current is unable to store at any point in a given circuit. This is the Kirchhoff's first law. Kirchhoff's first law is based on the conservation of charge. Now, for better understanding, we are going to solve the problems on Kirchhoff's first law, and this law is also known as KCL, Kirchhoff's current law. I will take one problem here. Let us consider one example circuit. Here, the 15 amperes current is passing through this resistor, and the other side, the 3 amperes current passing through this resistor, and here let us assume I2 current passing through this resistor and I3 current passing through this resistor, and from here let us say I4 current passing through this resistor, and here I1 current passing through this resistor, and here current is equal to 5 amperes, here current is equal to 8 amperes. Now the circuit is clear. This is one example circuit. Now we have to find out the unknown values I1, I2, I3, I4 by using KCL. The Kirchhoff first law is also termed as Kirchhoff current law. Now how to find out? First of all, you have to find out the junction points. This is the junction point, that is A. This is another junction point B. This is also a junction point C, and this one also a junction point D. Now how to find out the current at a points of A, B, C, D with the help of KCL? By using the Kirchhoff junction law, if I take A here, by applying the KCL at point A, by applying KCL at a junction point, at a junction A. If you observe, this is the A. What are the incoming currents here? 15 amperes. What are the outgoing currents here? 8 ampere. Here what are the outgoing current? I2. By applying KCL, we already know that the sum of the incoming currents is equal to sum of the outgoing currents. How can I write here? 15 amperes, nothing but 15 is equal to, I will write 8 plus I2. The 50 is the incoming current towards the junction, and the outgoing current is 8 amperes, and I2. From this, I2 is equal to 15 minus 8. What is the value? 7 amperes. Here, what is the I2 value we got? 7 amperes. In same way, if I want to find out the I3, I have to take the junction point B. At that junction point, I have to apply KCL. By applying KCL at a junction point or at a junction B. If you observe B, what are the incoming currents? This is B. What are the incoming currents? I2, we already know that I2 value 7 amperes. What are the outgoing currents? Here one more incoming current is also there. What are the incoming current here? 3 amperes. What are the outgoing current? I3. By applying the KCL at that particular junction point, we can written as sum of the incoming currents is equal to sum of the outgoing currents. What are the incoming currents here? 7 plus 3 is equal to I3. From this, I3 is equal to 7 plus 3, 10 amperes. By applying KCL, we got I3 is equal to 10 amperes, I2 is equal to 7 amperes. In same way, how to find out the I4 value? By applying KCL at C. At C, at junction point, at junction C. What are the outgoing currents, ma'am? Outgoing currents I4. This is also outgoing currents I4 plus 5. What are the incoming currents? 8. The sum of the incoming currents is equal to sum of the outgoing currents. 8 is incoming. 8 is equal to sum of the outgoing currents 5 plus I4. From this, I4 is equal to 8 minus 5. From this, I4 is equal to 3 amperes. We got I4 is equal to 3 amperes, and one more junction is left here. By using this junction point, we are able to find out I1 at, by applying KCL at junction D. If you observe, what are the incoming currents? I3. What are the outgoing currents? I1. This is the D. And here one more incoming current, that is 3 amperes, and I3 10 amperes. I1, how to write? Sum of the incoming currents is equal to sum of the outgoing currents. 10 plus 3 is equal to I1. From this, I1 is equal to 13 amperes. I1 is equal to 13 amperes. If you observe, by using KCL, we can easily identify the unknown currents. I2 is equal to 7 amperes. If you apply the KCL here at a junction point A, what is the incoming current? 15 ampere. What is the outgoing currents? I2 and 8. By applying KCL, sum of the incoming currents is equal to sum of the outgoing currents. 15 is equal to 8 plus I2. From that, I2 is equal to 7 amperes. And here, this is one more junction. By applying KCL at this junction, we got I3 is equal to 10 amperes. In same way, by applying KCL at this junction, we can able to find out I4 is equal to 3 amperes. Like this, by applying KCL at this junction, we are able to find out 13 amperes. Now, is that clear to you? By applying KCL, we can easily solve the circuit. We can easily find out the current in a given complicated circuit.